Hello, welcome to my video. My name is Sohail Mortazavi Manish. I am in MBA program, and this is a project for a data analytic course. I decided to investigate the CO2 emission. I have a chemical engineering background, and that was one of the reasons that I was interested in this topic. In this project, I will explore the CO2 emission over 50 years. Also, I will investigate the key predictors of the amount of CO2 emission of a country. And based on those, I will discuss some of the opportunities to reduce the CO2 emission. The motivation to choose this project was the Paris Agreement. In 2015, 195 countries agreed to limit the global temperature rise to below 2 degrees C. This can be done by reduction of CO2 emission and other greenhouse gas emissions. I was interested to answer these questions. What is the global trend of CO2 emission over time? What are the top CO2 emitter countries? Is there any sign of improvement in reduction of CO2? And which parameters significantly contribute in the amount of CO2 emission of a country? These parameters can be used to develop a model that can predict the CO2 emission of a country. The data required for this project was automatically scraped from multiple websites using RStudio software. The websites include Wikipedia, GitHub, and VP Statistical Review. After combining the data from all sources, I created a database. Then I investigated the global trend of CO2 emission between 1965 to 2016. In this graph, the y-axis is the global CO2 emission in million tons per year. As you can see, there is an increase in trend of CO2 emission over years. Around the year 2000, the CO2 emission started to increase more rapidly. And around 2011, you can see that the CO2 emission increases less rapidly comparing to the years before. Now, if we investigate the trend of CO2 emission per capita, here we can see in the y-axis the CO2 emission per capita in tons per year, and also the diameter of the circles represent the total CO2 emission globally. Larger circles means higher CO2 emission. Also, the color of the circles represent the total emission of CO2 globally. Dark red means more emission. This graph shows that between 1965 and early 80s, there was a rapid increase in CO2 emission per capita. Then until 2000, the CO2 emission per capita was relatively steady. But between 2000 and 2011, the CO2 emission per capita increases rapidly. And then after 2011, the CO2 emission per capita started to decline slowly. It can be seen that in terms of global CO2 emission per capita, there is a slight improvement and slight reduction. However, the total CO2 emission is still increasing. Now let's investigate which countries were among the top CO2 emitters in 2016. China and United States were the largest CO2 emitters in 2016, followed by India, Russia, Japan, Germany, Iran, Saudi Arabia, and Canada. Investigating the CO2 emission per capita for different countries in 2016 identifies different players. As you can see, the mean global CO2 emission per capita is about 4 tons per year, the green bar. And Qatar, and for Qatar, the CO2 emission per capita is about 40 tons, which is about 10 times more than the global mean CO2 emission per capita. Trinidad is the second highest CO2 per capita emitter by 30 tons per year, followed by Kuwait, Bahrain, United Arab Emirates, Saudi Arabia, Australia, United States, Luxembourg, and Canada. So far, we explored the trend of CO2 emission. Now let's see which parameters have significantly can be affect this the CO2 emission per capita, and which parameters can be used to model the CO2 emission, the total CO2 emission. In order to do that, you conduct some hypothesis tests and address this question formally. Here I have listed the candidate factors that might impact the CO2 emission of a country. The first candidate predictor is population. If there are more people in a country, probably the amount of CO2 emission would be higher. The next parameter is GDP, and we want to see, does the economic well-being or prosperity of a country influence the amount of CO2 emission. The next one is oil production, and also the other factors are fossil fuel consumption to generate electricity. And among those are oil to electricity, gas to electricity, and coal to electricity. Also, I looked at the solar and wind power capacity for a country. I wanted to know if the capacity of the solar and wind energy generation of a country impacts the total CO2 emission of that country or not. Here, the null hypothesis state that there is no linear relationship between parameters and the total emission of CO2 emission of a country. And the alternative hypothesis states that there is a linear relationship between CO2 emission of a country and the candidate parameter. Now let's look at the results. The linear regression calculations are conducted by RStudio. First, I included all of the parameters in the model. Here we can see that the p-value of each parameter, and below we can see the variance inflation factor, which is an indicator of the multicollinearity between the parameters. The p-value of solar and wind energy capacity is greater than 5%, which means these parameters are not a significant predictor for total CO2 emission of a country. In addition, the VIF values of solar and wind are very high. Therefore, I dropped solar and wind energy capacity from the model. Now, by removing the solar and wind energy capacity of a country from the model, the VIF shows no significant multicollinearity between the factors. But the p-value of GDP per capita is higher than 5%. Therefore, it means GDP per capita is not a significant predictor of the total CO2 emission. Now I remove this GDP per capita because of that, and I include a new parameter, which is the multiplication of population and GDP per capita, which is basically the GDP. Although introducing this new parameter does not make the parameter's p-value to exceed 5%, but it causes high multicollinearity between the parameters. Also, introducing this additional parameter did not improve the R-square of the model, which is the measure of the accuracy of the model. Therefore, I remove the GDP from the model. Here I remove the GDP from the model. The results show that all of the p-values are close to zero, which means all of the remaining parameters are significant in predicting the total CO2 emission of a country. Also, the VIF numbers are small, which means no significant multicollinearity. This R-square of the model, in this case, is 98.9%, which is pretty good. The hypothesis test indicated that the population, oil production, and use of fossil fuel to generate electricity are the most significant proxies to predict the CO2 emission of a country. And the economic prosperity of a country is not a significant predictor of CO2 emission. Also, the capacity of the energy production of a country using solar or wind power does not impact the total amount of CO2 emission of that country. It means that currently the scale of energy production by fossil fuel is so much higher than the energy produced by wind and solar, and that makes them insignificant compared to fossil fuel energy production. If the order of magnitude of energy production from alternative energies is the same as fossil fuel or more, then we can include them and include the alternative energies in our model. To evaluate the model, I compared the data for CO2 emission, the x-axis, and the calculated CO2 emission of the countries, the y-axis. The black line indicates the perfect results. If the model predicted resulting is exactly the same as the data, the circles will be on that line. This graph shows that the model is pretty good, and the prediction of the CO2 emission of a country can be modeled using this regression model. To summarize, the trend of global CO2 emission indicated that the total CO2 emission globally increases each year. However, the CO2 emission per capita began to decline between 2012 and 2016. Although it is a sign of improvement, but it is not enough to reduce the total amount of CO2 emission. Also, the top CO2 emitting countries, such as China and the United States, should focus on reducing the fossil fuel consumption. Even a few percentage of reduction of CO2 emission in these countries impact significantly on the total global emission of the CO2. Here we can see that the top CO2 emitter countries per capita such as Qatar, must target the global mean CO2 emission per capita and increase the efficiency of their process and also limit the fossil fuel consumption. The key factors identified here that were significant predictors of the total CO2 emission of a country are population, amount of oil production, amount of fossil fuel consumption to generate electricity, such as oil consumption, gas consumption, and coal. Also, the short solution is to be more efficient, efficiently use the fossil fuels for electricity generation. And the long-term and moderate, medium-term solution is limit the use of fossil fuel and eventually replace this fossil fuel as a source of energy with alternative sources such as wind and solar. So feel free to contact me for any discussions and comments, and I will be happy to respond. And these are the sources I use in this project. And thank you very much for watching, and see you soon.